Hey, in this video we're going to talk about properties in C#. Now, C# has a lot of really cool features, and some of them are meant to save you time, some of them are meant to help you avoid little typos and programming errors that can catch you up, and C# properties are one of those kind. Usually when you are in C#, like I am here using the Unity game engine, you are writing a lot of classes, and you might have to expose some data in order for classes to communicate with each other and for you to get information from a class. So let's say I have some integer stored in here, and if I make this public, then other classes, other code can access this variable, can modify it, can change it, and the class doesn't necessarily get notified that this variable has changed. And so sometimes you want to kind of protect those data members and hide them so that they can't be accessed directly. So normally you would make a member private in order to restrict access to it. But then if you still want people to be able to change this, you actually are trying to control the interface. And so if I left this as public, I don't have control over the interface. I'm just exposing a variable. That's the interface. If I make it private, I have to decide how is the rest of my code going to access this variable. It could access it in a roundabout way, like if you had a function do things, and maybe it increments your number, and maybe it returns that number in the end. So you could have a complicated interface where the user doesn't necessarily know that they're working with this myNumber variable because it's hidden, it's private, but they know that they can do things, and do things will have a result that they can count on. As long as it's properly documented, it's going to be pretty clear. But there are times when you want to access this variable directly. So you might write a function like get myNumber, where it simply returns myNumber. And then you might write a corresponding function, set myNumber, where you give it an integer and it directly modifies that variable. So this pattern is really common where we have a getter, which is also called an accessor, or a setter, which is also called a mutator. So when we want to get information, we'll use an accessor, and when we want to set information and change it, we use a mutator. And this, like I said, is a pretty common pattern when you want to hide a variable. You don't want people accessing it directly, but you still want to enable some way to interact with that variable. In some cases, you might want only the getter, and so people will be able to read from this class and find out what myNumber is. And sometimes you only want the setter part, the writing part of this, changing the number, and you don't want them to be able to ask what the number is. You just want to get information from the other code by them sending you a new number. So this is kind of repetitive if you want to do this for a lot of different variables. So this was just for one variable. I had to write two separate functions. I had to make sure I got all these right, returning integer, accepting an integer, writing the implementation for it. And that can get kind of tedious, and that's what C# properties take care of. Instead of writing my own getter and setter functions, C# can write them for me. So let me create another variable. It's going to be an integer, and I'll call it other number. Very creative. And this time I'm going to use this, this different kind of syntax. It's not exactly a variable here. This is a C# property. And in these curly braces, I can write get and I can write set. And just like that, C# will generate a public-facing getter and setter for some variable that I'll just call other number. Now, other number is not the actual name of my variable. It's the name of my property, but I get to treat it like a variable. So if I, in any old function, I could say other number equals 5. And that's going to use the setter function automatically. It looks like I'm using a variable, but I'm actually calling a function that's going to assign the value 5 into some hidden variable behind this other number property. You can define custom getters and setters with this syntax as well, if there's anything in particular you want to do. So let's say for get, I wanted to instead return my number. I could do that, and I can use my number as my private backing variable instead of the one that other number normally would come with. And I can change set so that it does my number set equal to, and then I have to use the value variable that this notation gives you this value automatically. So value is going to be an integer provided to your set function. And you can space these out so that they look more like functions if you really want to. They follow the same syntax rules as functions, but they have this this value is a kind of a secret argument that you don't have to declare. So it can start looking like my getter and setter down here if I need to do more complex things here. This might come in handy if you had originally done other number as a public integer, and then you want to change what exactly it does. Maybe you removed the my number variable from your code, and you want to just replace this with some other calculation. And maybe you want to still support a setter, but maybe it's not that important anymore, so you just don't do anything when someone tries to set other number. And what this has done is it's preserved this interface. I haven't broken anyone else's code. I've just changed what this class does internally. And some code might depend on the functionality that's happening in here when my number doesn't actually get changed. But what you achieve here is preserving this getter and setter kind of interface without exposing the details of how your class is implemented. It's separating interface and implementation in some way. So why do these exist? It kind of seems repetitive or redundant. Maybe it saves a little bit of typing sometimes, but then you have to remember this whole other kind of syntax here. Well, what it does is that it does simplify the creation of a uniform interface that uses accessors and mutators. The way that I did it further down here, where I said get my number and set my number, someone else could have named this something different, like access my number, or what is my number, or something like that. And that's not very uniform. C# properties enforce a conventional style that is going to be the same for every programmer that uses them. You just refer to the name of this, what looks like a variable. And if things change in the implementation of this class, the interface will be preserved without having to keep like an obsolete variable around just because it was made public. If you stopped using your public integer, you would have to just leave it there so that people could still expect to access it and it wouldn't break existing code. So this is how C# properties work. They're used in a lot of places throughout the Unity engine. If you look at, for example, transform.position. Transform.position is accessed through one of these properties. So transform.position, you can see, where is it? Okay. You can see it's got that gear symbol, and it says transform.position get set. So it has its own kind of hidden backing variable that is a vector3, and you don't get access to that. You can't change it directly. And this is why you can't do transform.position.x equals 5. This is not going to work because transform.position is a property and you cannot mess with just the x part of it. You can read this property, so I could print out the x value, but I cannot write directly to it. Because that's not using my property the right way. What I have to do is follow either getting or setting. And to set this variable, I would have to pass in, using that setter function, some other value of that same type. So 405. So this is why you cannot just set one single component of this transform.position. If you had your own vector3, you could set it all you want. But once you start using properties, you have to either set the whole thing all at once, or well, that's the only option for setting. And for getting, you can get it and then access the components of it. So that's how C# properties work, and I hope you start using them in the future. They're really, really useful for just keeping your code consistent and avoiding a lot of additional typing and potential typos. I'll see you next time.